Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks playground. So this will just be another day of trying to bash out, I think, day 29 of some computer science theory, just getting into algorithms. So we'll do that, but just like maybe just spend a minute or two on just some updates. So I am at the time still doing here on my server. So this is my basically the window or my little Linux server, and it's running the Codex CLI on a cron service all night long. I still have kind of working out some bugs where I have to like restart it every morning. Just some piddly stuff that's kind of typical, I guess, that I would run into. But let's see what it made today. So it is like making, what kind of app is it making? Okay, so it's still making, I'm just kind of curious so there's a specification to building automation system, and it's using an HTTP server that's built into Python. It keeps on making this, so I have to, whatever, it's kind of cool. So like we're giving basically artificial intelligence codex through OpenAI, running it once an hour. It makes a couple API calls, and it's slowly building this thing little by little through a specification, and we're telling it to basically check the boxes as it builds it. So it's interesting to me, like if you give AI just a generic specification for software engineering, it's actually just using the built-in HTTP server that's built into the Python programming language, which to me, I think this is only made for testing purposes, not a production web application. Like the Fast API framework or Django or Flask, it's actually using some testing thing built into Python, but whatever, it's kind of cool. I still have yet to show you like what the front end will look like, and it's making authentication and everything. So it's building itself. So it has built a little bit of the front end, where it should be building everything in React. I don't know. So we'll have to get more into this. Yeah, I'm just really curious now what exactly it's building. That doesn't look like React. It looks like plain vanilla JavaScript. But so yeah, let's keep on chugging along. So this is like the build spec, which we'll have to get more into this, like exactly. So like right at the moment, like we're basically giving it everything that we've done in this course so far, this YouTube example of how to do BACnet reads, BACnet writes, priority array, the whole 9 yards, calendar widgets. And then it is supposed to go through and there's a skill like we've been talking about. So like basically the AI agent, every time it wakes up from the cron request, it is supposed to go through like a checkbox of what it needs to do at this run, and then it'll look up how to do things. So keep remember that the AI doesn't have, it needs to write down what it did last and where it's at in a checkpoint. It doesn't have memory, so it's like a PhD in 1,000 different topics with the worst case of amnesia. It needs to wake up because it doesn't remember what it did last unless it writes it down. So that's what we're kind of building here. There's an acceptance criteria, and then there's build checkpoints that it needs to comply with. So this is still a work in progress. I think this is all I'm going to talk about it today, but we'll keep on doing this little by little. And what is interesting, there's just like several bash scripts that it's making, so it's interesting. So writing its own tests. So yeah, cool. So it's, yeah, and it's keeping a log of like what it's doing. So it should be interesting, but it's going together, coming together a little slowly, but it'll get better and better. I have full faith in that. Okay, so another thing I wanted to also just kind of chat a little bit about, there's another project called Ollama. I'm sure people have heard of it by now, but you can run models locally. Yeah, you can even power OpenClaw with Ollama. So this is the future, you know, in all this stuff. Instead of paying for codecs, there's also some really loud lawnmowers outside my window, so hopefully it's not too annoying. So like right at the moment, we have to pay for codecs through the CLI every time this wakes up. So basically what I'm trying to do is manually throttle that I maintain my 5-hour usage limits through here, and also my weekly limit. So I'm just kind of manually using a cron service in Linux that it wakes up once an hour, and then in that hour it makes 3 API calls. The mini model makes 3 API calls to do the software engineering, and then the GPT 5.5, the expensive one, is critiquing that, and then basically making the prompt for the next cron service go around for the mini model to take off. So it's kind of a guess and check for me of like maintaining my usage limit. Just a sip of coffee here, 1 second. But the point being, it's like, it's just doing a teeny bit of work once every hour, just a little bit of work every hour. It's just like, but this makes me think, so these results are really fast, that it can, you know, get all this data from the cloud API in the vast amount of time. It's just sitting there waiting to run again, because the GPU inference time in the OpenAI data centers, you know, goes really fast. You know, that whole networking, you know, it's lightning fast. But if you run Ollama locally, so this is the Ollama site, they even have some paid stuff I think you can do on the internet. So like someday I think hardware will become cheaper, and I think if you have a Mac, you can run this stuff even better on the Mac hardware and GPU. So this is my Windows machine. I only have a CPU on here. I don't have any GPU, but I have played with Ollama a little bit, so I can just go Ollama. This is just a little local app that comes up. So I'm really interested in playing around with these Gamma models that I think are made by Google. Just zoom in, like about as far as I can go. So the Gwen models I think are something to also play around with, but you know what I should do is bring up, let's see, I can't remember, Windows system information. Maybe there's like I think there's some kind of performance monitor dashboard in Windows. Where is that? Performance monitor. Processor. It would be kind of interesting just to see CPU usage here in memory. Maybe I should do a little bit more research. I guess I thought this would be a little bit easier to monitor. And of course, I don't really know much on the Windows side of things. Linux is a little easier in this. There's just like a few utilities. But basically the point being is like, hello, it's really slow. Hello, how are you? Can you make me a Backpipes 3 read request script, please. Okay, so like what it's doing on my CPU, which I have 32 gigs of memory, not much, but good enough for ordinary, stuff I do as like little analyst type work or smart building work, recording YouTube videos, playing around with BACnet. So it made it already. So it's going. Yeah, look how slow it's going. So it's hopefully you guys can see this. Hello, I am doing well. I am happy to help you with bagpipes 3. Okay, so like another thing that's going on too is I think that this model that I'm running locally, this Gamma 3 12 billion parameter model, is quantized. I think the word is, it's compressed. So if there's like a model that has like floating point precisions, like a kind of floating point, the same thing we've been doing before, it will, a compressed model that is more optimized to run on CPU. It's, I think it uses whole numbers. Everything's rounded. Yeah, I can already tell that this is wrong. It's nowhere near right. But it has been trained on bagpipes. So this is legacy bagpipes it's trying to use. So it's trying to make a BACnet script, but that's not right. Garbage. It's kind of like hallucinating, I guess. So point being is, where am I going with this? So like in the test that I'm doing on Python BACnet Active Playground, as it's making BACnet a building automation system, whatever we're doing with it, it's like we're doing some kind of model routing there where really simple requests, we're using the mini model to build all of the software engineering, and the more expensive model is kind of doing the critique work. But what I think the future in all of this is like, this will be the mini model, and then we'll still use the enterprise model, like the GPT 5.5, to review it and have it, do its thing. So like, what I want to do is play with, at some point in time, we're not here yet, is since I need to maintain my codex usage limits, like I can only do a few API calls every hour, like I could, look how slow this is going. So like if I can only do a couple calls a day on the enterprise model, some simple tasks is like, this guy could be slowly chugging along, and very slowly. And we'll probably play around with like how to throttle it. So like we just use that, maybe one call an hour to the enterprise model, GPT 5.5 on the cloud. And then this guy will be the workhorse under the hood. And then the enterprise model will kind of tell it, what to do, critique it. The critic is really common, I think, in AI engineering, that the more expensive model does the critic, and then the cheaper stuff kind of builds a lot of things. So I think like this is, we'll have to play with this in the future. And then with more context, I think if I gave this model more context, it might be able to make it better. And it's free, so this is completely free, not to mention. So yeah, and it just makes sense. Like if we have to throttle our usage to maintain our subscription API calls, yeah, it just makes sense. And plus, like a lot of the YouTubers say too, like to start getting used to running models locally, it's the future. We'll all be doing this probably, and then only making a few API calls per hour, per day, to the cloud, to the enterprise, the big beast running on the cloud. And then we can just, do the bulk of our work will just be on these piddly little models that are free running locally. I just need to build, I'm just dying to fork over some money to play around with building maybe something that has a GPU on it, and just getting some more oomph, something with more memory. So maybe I'll even put that on YouTube and just this is fun. Okay, so look how slow it's going. But okay, we should get back to doing some algorithms. So this is kind of like where I'm at. The next thing I'm maybe tomorrow. So it's probably, I'm just gonna close out of this. It's probably pinging my usage. But the next thing I want to play with, maybe we'll do this tomorrow, is we'll run a test of using Ollama, the same model, and we'll run this locally of the same silly joke of building automation system regarding why the air handling unit divorced the chiller. So we'll do this locally with Ollama, and then we'll calculate an inference time, so the time it takes to pump this out. And I guess we'll use the operating system then to just save this result to a text file, and then we'll also use the Codex CLI. This will be really fast. And YOLO, that's our argument for you only live once. So this model basically just wakes up, dies, does its task, and forgets that it did anything. The operating system kills that process. So, just to start comparing some of this, and mostly this will be elapsed seconds that it took to, ping the cloud, run inference on the big beasts in the cloud, and, bring it back again. So this will run really fast, and this will go really slow. But the point being is that this costs money. This has to be maintained by your AI subscription, and this guy doesn't. So let's do that tomorrow. Okay, so enough about that and the other Codex CLI thing. Okay, and let's try and bash out one lesson a day. I feel like if I don't do this, I'll just start, not doing anything. Okay, so day 29. Anyone that does not want to play around with computer science theory, I still think it's really important to study this stuff. But if you're the expert that already has the degree, feel free to sign off. I'm not. I do not have a degree in computer science, so I have to teach myself, basically. And the more that you can learn foundational levels of algorithms and data structures, kind of like this computer science 101 of what probably the freshman year level of a computer science degree, what they study, it will seriously make you a lot better in AI engineering, also software engineering in general. It's just very well known that having a foundational concepts of algorithms and data structures will you'll outperform someone that does not have that. Okay, so where are we? I have to open up my just have to open up the script lesson. Okay, so I just have to open up VS Code. Okay, so this is our script from yesterday. What do we have today? Day 29, min, max, and extreme event scanning. So this is getting into algorithms. Implement min and maximum with a single forward scan accumulator pattern. Use HVAC readings, duct supply, temp, zone delta as mental models. concept. Best to initialize best to the first element, and then for each remaining value, compare and update. This is one form of reduction. Okay. Many values to one summary. Find patterns. Same patterns finds longest run later with a small change of state. Okay, so this is, so it looks like we're doing a little bit of slicing of an array. So it looks like we loop through an array. Kind of not used to that operator, but this is kind of cool. So this is just a function that will print find max and find minimum. And it's kind of cool that it gives it to us in some data. If you're an HVAC technician or an engineer, something like that, in the HVAC industry, of this is the data that you would see in a air handling unit maintaining duct static pressure. A variable supply fan is pumping air into a ductwork network, and it's pressure. These are inches water column. Okay, so operators care about peak. All right, so this is why this matters. Okay, so this is just another example about demand response, mini examples. Okay, so here we go, the big one. Micro exercises, right? Max, absolute ABS, absolute deviation, set points and actuals, assuming equal length lists and floats. Okay, so set points and actuals. So I think it's like saying like, what is the maximum deviation between a list of floats? Okay, so the absolute value, I have to wrap my head around this. Okay, so let's say this is, I'm just gonna copy this. Might be able to recycle this from yesterday. I just have to zoom out a little bit. It's almost like too far for me, so I think I can do, okay, hopefully you guys can still see that. So I might just do temp set point. So let's say our set point is just 40. Let's make it who cares? 40 degree set point for something makes no sense in the HVAC world, but I don't think that matters. Okay, so the absolute value would be the differences between these two numbers. I guess we just have to make these all the same. Whoops. Oh, don't do that. I just have to copy one more. Okay, we just have to see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so like what we could do. Alright, so remember we have to do a for. I'm just going to recycle this. This will be, let's see, we need to have a function. This is the name of our function. We'll get rid of that. So then we have to zip these two. If you remember the zip utility in Python, it combines these two values so they're next to each other. And then these are location, and then it looks like we call set point first, and then temp. Okay, so the first thing we want to do is I'm just going to call these all the same. Let's just check this out first. Let's see, so this should be in the root lesson. So Python script lesson. Okay, so it's printing these out, and then the next thing I want to do, Python should have ABS. Okay, so then we want to print the absolute value. So we could say, I guess I could just do this. Set point minus temp ABS. Okay, so these are the absolute value of those. What was this? So write a function, write an absolute value. Write max absolute value. Okay, so then we just have to find then the maximum. So I'm just gonna make a variable here called max. I don't think we can call it max because Python has a max built-in utility, so we have to call it something unique, assign it to value of 0, and then we just say, I'm just going to say this, current value equals what we just printed, and then just the if statement, if current value is greater than or equal to max value, max value will equal the current value. And at the end, we want to return max value. We could even say data found equals that, and then print this. Or we could just print the whole function call. See if this works. Ooh, found 11.6. Oh yeah, I guess that is one. Okay, so like it did find the right one. So it returned that. I think we have that solved. What it did is that I iterated through each one of these values and returned the max value. Then I think the computer scientists would then study the efficiency of the algorithm and say this is O to the nth complexity, or something like complexity, saying that there could be more efficient ways of finding the max value, which I don't even know if our little algorithm thing, if we'll even get into that, but just kind of have like a mental note that computer scientists in general, they would play around with, this could be massive sets of numbers, and they will play around with different algorithms, internal workings here that can more efficiently find that, what we're looking for. Algorithm complexity. I think there's like time complexity and memory complexity. So that's kind of like what the computer scientists study is what's the most effective way of doing this stuff. But this is really basic. Okay, so we figured that. Okay, verify your min and find max. Match Python's min and max on a random list of 10 integers. and integers. Okay, so I'm going to delete all this. Gosh, we could even use random here. Import random. That's built into Python. I might just Google this. Python list of, let's do 50 random integers in a range. Okay, so this right here, this will generate a big list of random numbers. Okay, so look at that. That is a, gosh, no, I think I shouldn't have deleted my code. I'm going to do all this. Okay, so I'm going to try this now. Import random. I'm not going to do that, so then I just need to modify this for a list. I'm just going to call it data. Don't need zip anymore. I'm just going to use this for value in data. Don't need that anymore. So I'm just going to call this function find max int. Then I am just going to print this directly in here, wrap this into here, random list. We will print it too. Okay, so it found 94. So this little print right here, it printed this. Inside of here, it just came up with 50 random integers between 1 and 100, and they're unsorted. And our little function here found 94. It was the highest. And then Python has built-in utility for this. Print max random list, and let's do print min random list. Whoops, min. Cool. So my function by hand did it, and then also Python's built-in function did it. So it's not all coding languages may have a utilities built into it, but like modern ones like Java or C++ or C# or something will have, utilities to massage numbers, do kind of things like operators and built-in utilities, work with strings or whatever. But if you get into a low-level coding language like C or something like that, you would probably have to do all this by hand. So this was just an exercise for us to kind of know what's going on in here. And what's built into Python could have more efficient algorithm built into that as well. So just keep that in mind. Under the hood, what's built into the programming language is probably the most effective and efficient PhD computer scientist level way of doing this, but I don't think we'll get into that level. Okay, so alright, so it wanted us to do a verify min. Actually, this was supposed to be find max. Find max. Whoops. And we also have to do a find min. said. And it's, I'm just going to change the word. Let's call it value. Except the only difference we need to make is this in our operator here from less than. Okay, so then we just have to do another one of these. And then find min. Sometimes I like to do another empty print statement here. And this should work. It will return to 0. Okay, so this was not equal. So we got something wrong here. Okay, so if we want to find, oh, maybe we need to find, what did they do in here? Smallest value. So I guess they're just picking, I think this just means the first value in the array. So I might steal that. So this would be data slicing. We should probably do that here too. So what it's doing is it's just going to look at this first value. So for both of these function, it's going to look at the first value. If the second value is greater than, it's going to say this is the biggest number, and then this one, and then this one, and then this one. So or minimum. Hopefully that makes sense. Okay, now they match. So our min maxes match each other. This is our empty print statement right here. So we solve that one, that our do-it-yourself style matches what's built into Python on min and the max. So hopefully that makes sense. That it's just looking at this first value in the list or the array of numbers, and then the for value in data, you know, we're plotting one at a time, and then if that value is greater than or equal to, it's comparing one at a time. If this one is greater than this one, then it finds the max value. It'll just retain that and then return it unless another one it comes across as greater. Kind of fun. Okay, so cool. So we got that one. Okay, here we are. So stretch. Return min and max and indexes in one pass. Ugh, this is annoying. So, okay, so basically it wants us to combine these, I bet, into one function. So maybe I will just say min val so I'm going to start putting this into this same function. But we could just put like that. Okay, so we'll want to return this. Okay, find min, max, and indices. Okay, so what do we got here? so now we have to do some indices. So that's where we need the enumerate. So like we'll need to do for index value in data, then wrap this in the enumerate function, enumerate, because that's what the enumerate function does, is it gives you the ability to have an index. So an index is index 0, 1, 2, 3, 4. This is like really important computer science algorithm stuff, is everything has an index. Okay, so then we need to define this. We can just define these as 0, zeros, 0, 0. Okay, so then if we do max first, and then we can probably think this will work. Min index equals index. Then we'll want to return this. This will return one big tuple, which we've talked about. Okay, so let's just study this a little bit. So when we pass in this list of random integers into our function, it's going to assign immediately the max value and the min value as the first values in the list, and then it'll iterate through one at a time. And then we're going to use the enumerate function to kind of plow through it, keep track of each value, and then it'll also keep track of an index for us. So as we plow through each value in the list, we just have these working functions. If the value is greater than or equal to the max value, it will assign the max value. We found it will equal that, and then we'll also assign the index at the same time too. And then same thing for the min value. If the value, then we're plowing through this list of numbers. If the value is less than or equal to a new one that it finds when we plow through it, it'll assign the min value and the min index. And then once we plow through all the numbers, we're basically returning what we found after we plowed through them all with here in a tuple. Oh, did it work? I don't think I saw any. Okay, so it worked. It found 100 and 100 and 6 and 6. Okay, what I'm really curious now is to just plop this into ChatGPT and then to see. There might be a more efficient way of writing this. Key takeaway: min and max are accumulator algorithms. They mirror how fault detection diagnostic summaries are computed on bounding windows. Same idea, smaller code. So that's interesting. It gave us in HVAC fault detection diagnostics, which maybe we'll get into, like we do in the Open FDD project. I have to think about that. Okay, let's just see. Is this how's this? Pop it in the ChatGPT. Looks good. One small thing. Because you use the greater than and less than equal, there are duplicate min max values in your function returns. Your function returns the last index where they appear. Oh, okay. I guess that is so it just didn't use the greater or the equal operator, which makes sense. All right, so I think I might cap it at here, guys. Like tomorrow, let's look at lesson 30. My goal is gonna try and complete this. I'm really good at starting a game of Monopoly and then never finishing it, but I love starting things. Okay, so frequency table, how often a key appears. Cool. Okay, so kind of fun. So frequency counting is the next algorithm. We'll do that tomorrow. And then also on the mental to-do list is like, let's do the Ollama model test, and then keep checking back on this building automation system that we're trying to build with AI and our AI code generation. So it's going really slow. What the heck? There we go. So like tomorrow, let's run this just for fun. Compare our results with Ollama running locally. I've been meaning to do this, and I probably will be like a 2027 hobby to actually build like something with a GPU. I haven't played around with building a computer since I was in college about 20 years ago. So yeah, why not? Maybe this will be fun stuff to come ahead. So hope you guys are liking this. Talk to you guys tomorrow.